All right, so in this lesson we're going to be focusing on scale copies, so just kind of an introduction to it. So we're going to go through a couple examples and see how, or see properties of those scale copies. So this first one, you're given the original right here, the original drawing, and we're looking at the A through E and see which one is similar or how is it different. So if we look at this first one, A right here, compared to the original right here, we notice that it's different because it, height-wise, it gets a little bigger, but it gets skinnier. So what it does is it skews the original picture. Okay, the second one is going to be the same thing. B is skewed, it shrinked and then widened. So now the picture, it does not match the original drawing. C, that one is a good scale copy. So, or is a scaled copy. It is the same shape, it's just smaller. So they not only made it shorter, but they also made it skinnier too. And the same is going to go with D here. D, it's the same shape. It's all proportional to the original. This one's just blown up, so it's made a little bit larger, so both vertically and with width and horizontally. Okay, so C and D, these two are your scaled copies. E, you'll notice it's at a slant, so the original drawing gets skewed and changed from its original. So that one is not a scaled copy. Okay, so the two scaled copies were C and D. They stayed, they kept the same shape. They were just either smaller or larger. Okay, so what does scaled copy mean? So the way I define it is that a scale copy is a copy of a picture that keeps the same shape but may change size, so make it larger or smaller. I'll just say increase or decrease in size. Okay, so it's going to have the same shape, and with the portrait it's a little hard to tell, but we're going to move on to a few other things, drawings where it's easier to tell that they're the same size, or that they increase by the same size. Everything does. Okay, so right here we're given 8 Fs. This F right here is the original one. We want to look at all these other ones and determine if they are a scale copy. So they change, they might be bigger or smaller, but they're still proportional to the original. All right, so looking at this, we note the number of units here for height. So this one is 6 units. The original one was 4 units. So we're looking for a number that you'd multiply 4 by to get 6. Well, that is 1.5. Okay, so now if this is a scale drawing or a scale copy of the original, if we multiply every length by this factor, and it turns out so like this top here is 2, if we multiply that by 1.5, you should get 3, which that does align with this dimension here. And so far the height and then the length of the top one follow that. When you multiply by 1.5, it gives you the length of the next copy. Okay, same thing with this next one. We have 1 dimension there, or 1 unit width. If you multiply that by 1.5, you get 1.5, which is that dimension right there. So this one is a scale copy. Okay, drawing 2, we're going to do the same way. So we're going to look and see the height of this. So the height is 8. The original height is 4. So that has a scale factor of 2. So now, if this dimension is 2 times the original length of the top, and this dimension is 2 times the original length of the middle line on the F, then it's a scale copy. So 2 times 2 up here equals 4, and that is correct. And then 2 times 1 equals 2, that one's correct. So now we see that, yes, this is also a scale copy. Everything's increased by a factor of 2. This one, just by looking at it, I can tell that this one there was no change in the height, but yet here there was a change of multiplication of 2. So this one is no. Likewise, drawing 4, so same thing. This drawing has changed. It's now a slant, not a straight line. So just by looking at it, we can say no. Okay, 5. 5 can be a little tricky. So once again, we see that the scale factor of 1.5 gives us this here. So that's correct. So that'd be 6. It checks out for the top one. So 2 times 1.5 equals 3. Now down here, 1 times 1.5 equals 1.5, not 2, right? This one is 2 units long here. Therefore, this one is not a scale factor. Okay, drawing 6. So just looking at it, you see that both the top and the bottom line for the F are the same length, which is not the case in the original, so this one is no. Okay, and then last one. So this is 12 units long. So the original one is 4. So we times 4 by 3 to get 12. So we got to now see if we multiply every length by 3, we get what is showing here in the example. So 2 times 3 is 6, which that one checks out. Okay, 1 times 3 is 6. Sorry, 1 times 3 is 3. And so those do check out. So this one is also yes. This one's a scale copy. Okay, so we identified all of the scales. It was drawing 1, 2, and 7. And this is just kind of re-examining by using what I just said. Look for that scale that you're multiplying each dimension by. Okay, now here, this just gives you a chance to actually draw a scale of your own. So if I said I want to do a scale of 4, so I'd multiply my lengths all by 4. So I know 4 times 4 is 16. So I know that's 4. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so there's my 16. Now, if this is 2, I'm going to multiply that 2 by 4 to tell me my length here. So 2 times 4 is 8. So 2, 4, 6, 8. So did I do that right? 1, 2, 3, 4, 5, 6, 7, 8. Yep, and now this is 2, so I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to multiply 1 by 4, which is going to give me 4. And there I've done a scale copy. Yours could look different. It could be a different scale. It could get smaller. But you're just going to multiply each dimension by the same number to get your next size. Okay. This next one, you're going to refer to the PD that I attached. So I'm going to go to that. And we're just looking for which ones match. So scale matches. Okay. So looking at A here, we have a 3 by 1 and a 2.5 by 1. So looking at B, if you multiply the width by 2, then you have to multiply the length by 2 for it to be a scale factor. So the top is 3, 3 times 2 is 6. Okay, so you have 1, 2, 3, 4, 5, 6 there. The bottom is 2.5, 2.5 times 2 is 5. So you've got 1, 2, 3, 4, 5, 6. Okay, so that doesn't work because you multiply the bottom by 2, you get 5, and this one has 6. So these two are not a scaled factor. Okay, looking at C, so they doubled it. You have 6 on top, and then you have 5 on the bottom. So that one checks out. So these two are scaled copies. Okay, looking at B, so you're going to do the same thing. It's a 6 in length for both the top and the bottom, and then it's the width of 2. So just looking at these, I'm going for one where the top and bottom look similar, which is D here. So I'm just going to check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have 4 here. So the original was 2 on B. So 2 times 2 is 4. So that checks out in this dimension. And then 6 times 2 is 12, which checks out in this dimension. Okay, and then if you count, you'll see that this one also checks out. It was originally 6, you multiply it by 2, and you get 12. And then same thing with this dimension. Okay, so that one checks out. So B and D are also scale factors of each other. Okay, and now you're going to do the same steps, and I'm just going to note which ones are, just to keep the length of the video down. F and G are, and you can double check and see what the factor is, and then J and H are. Okay, if you'll notice, I believe all of them are doubled except for F and G. That's a scale factor of 1.5. Okay, so that is the big takeaway from the lesson. Let's see, where was it? Okay. So the last thing is just going to go over a few things. Here they just want you to draw a polygon just to help you see if they are in fact the same. You can use it on that sheet and just count from one to the other, see if there's a scale factor that all the original scale when multiplied by gives you the new one. Okay, just a quick question they ask, if polygon A and B, which were not scale copies, if you could make a scale copy from that would satisfy both of those. That would be no, because if they're not a scale copy, you can't have a scale copy that's going to satisfy both of them. Okay, so just this lesson summary, the scale copy, it's two figures that are have the same shape, but maybe not necessarily the same size. Okay, that's just a brief description of it. All right, looking at these ones, you'll notice that all of these are scale copies of each other because they all increase by the same amount, both up vertically and horizontally. Down here, these two are not the same shape. This one is wider and shorter, and then this one and this one are not the same. This one is the same height, but it's just skinnier. Okay, so hopefully you defined scale copies in your notes. Refer back to the upper top of the video if you forget what that is. You can change it and put it in words that maybe you understand better, but it's mainly a copy of an original picture that has the same shape but not necessarily the same size. Okay, so last thing I want to go over real quick is just the lesson. So the first one, it gives you the original, the assignment, the 4 problems. Here's the original. Looking at these 4 drawings, which ones are scale copies? So if you look at this one, the height was 2, now it's 4. This width right here was 2/2, which is 1. In this one, it has went by 2. And then the width from base was 2, now it's 4. So this one is a scale copy. Scale would be 2. You multiply by 2. This one right here is not. It stays the same width, but it increases in height by 1. This one right here is not. It doesn't even look like the same shape. And then this one right here, number 4, is. It's just a scale copy of half the original size. Okay, Tyler says that figure B is a scale copy of figure A because all the peaks are half as tall. Do you agree with Tyler? Explain your reasoning. Okay, this one is, I do not agree with Tyler. Although the peaks are half the size, the width right here looks like it stayed the same. So not every dimension changed by half. Only the height did. So this one would be no. Okay, number 3, here's your original. Which ones of these look like it is a scale copy? So this one looks like they compressed it. Height has stayed about the same, so that one would be no. A is, and we're not needed to measure here, but just by looking at it, this one doesn't have as much of an oval. It's a little more compressed. This one, number C, is squished, but still the same length as A, and so that one is not. And then D is yes as well. This one's just a smaller copy of the original, but they squished it as well as they thinned it at the same proportional dimensions. So, okay, last one, number 4. This is just completing each equation. So 5 times 3 gives you 15. 4 times 8 gives you 32. 6 times 1.5 gives you 9. And then 12 times 1/4 gives you 3. When your outcome is smaller than your original, think of division. 12 divided by 4 equals 3. When you divide by a number, it is same as multiplying by the reciprocal, which is just 1 over that number. So this is equal to 12 times 1/4, which is the reciprocal of 4.